Okay, but I think first of all, okay, doesn't matter. You can go to Blackspace, download the tutorial question. Okay. TT, oh, no, not TT03. TT04. Okay. Can you check the mask entry? Okay, check the mask entry. I just want to know those students, these students, so that I can pay more attention to them when I teach, if possible. Han Jin Yan, are you here? Raise your hand. Jem Pranjit Singh, are you here? Mashuri Jonathan, raise your hand. Nobody. Muhammad Rafa. Muhammad Al Safiq. Muhammad Asri. Jun Hao. Not here. Okay. Somehow I teach 6 classes. This class has the most number of many more failure. Okay. So for those students who need to take the retest, you let me know. You can put an appointment with me. Okay. Okay. So the date for the retest is already announced in the Blackspace. Okay, so as you can see in the whiteboard now, okay, chapter 6 is about AC theory, and as usual, you should have done your OAL quiz before you come for this lesson. And objective is to understand about AC current and voltage, calculate the impedance, current and voltage. Okay, and okay, let me share. Did I share the screen and record? Share is recording, right? Yeah, it's recording. So AC stand for alternating current. It's a current that periodically alternates in direction. Okay, so for example, you can see this 3-pin part, right? The 3-pin part. Okay, is it AC or DC? It's AC. If you measure if you use some equipment to measure these 2 points in the 3-pin plug, you will see a sine wave. And this sine wave you also be very familiar already. So over here is the y-axis is the voltage, the x-axis is a time, and there's an important parameter for the sine wave called frequency. So let's say I say the frequency is 50 hertz. What does it mean? Okay, it means 50 cycles per second. Okay, and what is 1 cycle? If you look at the sine wave, okay, from here until here is 1 cycle. Then this is another cycle. So in this graph here, in this waveform here, there are 2 cycles, and 50 hertz means 50 cycles per second, and it's represented using this letter F. It will be important for the calculation later. So that's why I want to highlight this one. This F will be used in the calculation later. Okay, so let's look at the tutorial question. Okay, you look at this circuit. This is something new to you, right? And you see a sine wave here, right? So it's like common sense. So this is actually a voltage source. Because you see a sine wave, so it's a AC voltage source. And I just show this waveform to you. So just to tell you that if you measure the voltage source, you will see a sine wave. Okay, and then in the past, you all learn about DC, right? Okay, so in the DC circuit, when you want to represent voltage source, okay, you also know by now you have been doing this. So this symbol here is a DC voltage source, and this symbol here with a sine wave is a AC voltage source. Okay, so this voltage source you connect to a capacitor, right? Then frequency, just as I mentioned already, is important when you want to calculate current and voltage in the AC circuit, and it's given 400 Hertz. And you are asked to determine the capacitive reactance and current I in polar form. Okay, so these are the formula. Okay, in a DC circuit, okay, in a DC circuit, you have something called resistance, right? Then I equal to V over R. Now in the AC circuit, okay, in the AC circuit, we study, okay, just to let you know, in our module, we only study series circuit, that means resistor, for example, resistor and capacitor connected in series. We do not study parallel circuit, or our scope is only series circuit. And the formula will be something like that. If you have resistor connected in series with a capacitor, okay, for AC, instead of calculating the resistance, you calculate something called Z impedance. Okay, it's written here. So for AC, we always calculate Z impedance instead of just the resistance. Okay, so Z equal to what? R minus J XC. Okay, then you see from here, C in electrical engineering usually refer to capacitor. Last before the term break, we study one chapter on inductor and capacitor, right? So C normally refer to capacitor. So this capacitor in the AC circuit introduce something called similar to resistance in DC circuit, but in AC circuit we call it capacitive reactance. So you can just treat it like the AC resistance, okay? Okay, so okay, now coming back to this formula, XC. SC is a formula here, okay? So SC have this formula 1 divided by 2 pi FC. Okay, F is the frequency. That's why just now I mentioned frequency is important. Okay, this is where the frequency come in the calculation. Okay, so next you substitute F 400 Hertz. Okay, F is 400 Hertz. And then the capacitor here is 200 microfarad. You substitute already, okay? Micro is how many? 10 to the power of minus 6. So after you do calculation, you get 18.1, and it still use the unit ohm, just like the resistor. You still use the unit ohm. And then now we have calculated the SC. So we substitute SC into this formula. Okay, we have this formula. We substitute SC into here. Okay, so 18.1 is for the SC. Also 18.1 come from here. Okay, SC is 18.1. You substitute inside here. Okay, in this circuit, do you see any resistor? No, right? No resistor, that's why you put 0. Oh, I repeat again. So in this circuit, there is no resistor, so it's 0. Okay, then from here, 0 minus J. Okay, just to remind you, in fact, I sent you a message. I say, before you come for this lesson, you should revise your mathematics. According to my student in the previous class, they say they learn complex number last semester. So this is a complex number. When you see J, you know it's a complex number already. Okay. So if we continue from here, 0 you can just ignore. So it's minus J 18.1. And the question asks you to convert your answer in polar form. Okay. Ask you to calculate. Oh, I didn't say. Okay, doesn't matter. So you can convert this one to polar form. Okay. So this one, if you convert to polar form, you get something like that. Okay, a number and with an angle. Okay, so I don't teach math, but to help you to recall complex number, okay? Complex number, there are two forms. One is called the rectangular form, and then another one is called a polar form. Rectangular form is something like 2 plus j3. The polar form would be maybe like 5.3, then with an angle, then maybe 21 degrees, that kind of thing. Okay, so just to summarize, rectangular form is a number plus a something. Polar form is a number with an angle. Okay, so can you tell me this one, is it polar or rectangle? Is it polar form or rectangle form? Okay, so this is 1, this is 2, right? Okay, so this one, is it rectangle or polar form? 1 or 2? 1 or 2? Anyone? Can anyone tell me? 1 is rectangle, 2 is polar. So this one here, minus j 18.1. Is it rectangle or polar? No answer. Okay, the answer is rectangle. It's a rectangular form. And then what about this one? This one, you have the angle, so angle is called polar form. You need to know this because later on, when you do the calculation, you need to convert the rectangular form to the polar form. Okay, and then now we want to calculate the current. So this is the Ohm's law, voltage divided by impedance. Or for DC circuit, normally we divide by resistance. For AC circuit, now we have to divide it by impedance. And then voltage is here. Okay, sorry, voltage is given here. Okay, 115 0°. And then the impedance is given here is over here. Okay, so you have one a complex number on top and a complex number below. Okay, take note that for complex number, when you want to do division, you should convert the number to polar form instead of rectangular form. These are the rules. These are the rules. So I repeat again. Now over here, you want to do division, right? You want to do division for complex number. Make sure that you convert the complex number to polar form first. You cannot use rectangular form. You won't be able to do it. Also, this is the rule. Okay. Any questions so far? So first rule, division. Your complex number must be converted to polar form here. Okay, now second step. How do you do the division? How do you do a division? You can split it into two parts. The first part is the number. The second part is the angle. So we do the number first. Very simple. The number basically, you look at this one. 115 divided by 18.1. So this is the ordinary number. So you just use the ordinary way to do it. You just press calculator. This one divide by 115 divided by 18.1. So you should get 6.36. Okay, you can try. Okay, so this is the first part. Second part is the angle. Okay, second part is the angle here. Okay, so the rule is the angle on top minus the angle below. So the angle on top is 0, right? Then the angle below is, okay, 0, then you minus, right? Minus the angle below. The angle below is actually negative 90. Okay, negative 90. Okay, you come here and scan the QR code. Okay, so 0 minus 90, if you press calculator or you do your own calculation manually, it's 90 degree. Okay, so that's why you have the 90 degree here. So okay, so basically, just to summarize, for when you do divide two angle like that, basically is the angle on top minus the angle below. In this case, the angle below is minus 90. So you get 90, and this answer. And remember to put in the unit like ampere. If you forget to put, normally 1 or 2 marks will be deducted. Does it work? I think maybe have to go this way. Try this way. Also rectangles, right? Or maybe exceed the time cannot scan.
Honestly, because I had
Why? Okay, let me show you this one, see whether you can scan. Yesterday I have some problem also. Can. This one can. Yeah. That one cannot. Maybe it's not rectangle, is it? Okay. Okay, so coming back to the lecture. Okay, so question 4. Okay, question 4. Okay, I done already. Question 4. Okay. If you want, take a photograph of this thing. I will give you a question to do later. So you need to understand this question and the next question. Then I give you a question to do and submit. That means you do and show it to me lah. Okay. So okay, question 5. Can you spend half a minute to read the question? Okay, so in this circuit, you see an inductor here. And so same thing, you are asked to determine the inductive reactance. Okay, inductive reactance, do you see this? Inductive means inductor. So it's asking you to calculate the reactance from this inductor. And this is a final formula. Okay, just now I give you the formula is not complete yet. This is a final formula that can apply to all series circuit. And what I added here is just now was minus JXC. Now the new thing is plus JXL. So as usual, L here normally refer to inductor. Okay, so XL okay is actually inductive reactance. And take note of the difference here. For capacitor, it's always minus J. For inductor, it's always plus J. Okay, this is a rule. Every time you see inductor plus J, every time you see capacitor minus J. Okay, so now XL, what is the formula for XL? Okay, if you have done the OAL, it's 2 pi FL. Okay, and you will get 2 pi multiplied by frequency. So frequency is given here, correct? Frequency, similar to the previous question. And the inductor is 5 millih. Okay? Milli is how many? 10 to the power of what? Minus 3, okay. So you press calculator and calculate, you get 12.57 ohm. Also is similar to resistance. So the unit is still ohm. Okay. Now we move on to this one. Z equal, this is a general formula that apply to all series circuit. Okay. So I repeat again. In this module, the scope is only series circuit. We don't study parallel circuit. Okay. And okay, now based on this formula, and the circuit and the information, we substitute the value lah. Okay. R, do we have resistance here? No resistance, so 0. Okay, so resistance is 0. In this circuit, is there capacitor? No capacitor, so minus J0. Okay, now inductor we have calculated the inductor XL. Okay. Later on, then my attendance, right? So you come at 224. If you have the player, you just put in the remarks player, okay? Later on. Okay, so now so all this is 0, so you have J 12.57. So far is it okay? Okay, and as usual, we want to convert to polar form because we know that later on we need to do division, correct? Just as I mentioned already, if you want to do division for complex number, you have to use polar form. So if you press calculator, you will get this. Okay. Yeah, I forgot to mention. I have sent you, okay, how to press calculator to get to convert the rectangular form to polar form. I send it inside the MS Team. Later on, we can try in the next session. Okay. And now we move on to I here. The I equal to what? B divided by Z. Right. So B is 200 here. 200. Z 12.57, correct? Okay, we have already calculated this 12.57 here, so you substitute into the Z. Okay. And then okay, so this part here, how to calculate? Do you remember? I say that the number is one part, the angle is the second part. Okay. So the number part, you get 200 minus 12.57. Okay, can you press calculator, see whether you get 15.9? Can you try out? Okay, so and then as I mentioned just now, okay, for the angle, okay, for complex number, for the angle, what you do is the angle on top minus the angle below, so you have minus 90 degree here. Okay. Okay, so I think I give you the screenshot lah. Some student just came, okay, so I give you the screenshot. Can you do a photo, take a photograph of this one, class? Those who just came, I discussed 2 questions already. Take a photograph of this one, question 4. Okay, and next one is a question 5. Okay, these 2 questions I give you the solution. Next question you have to do it yourself and show it to me later. Okay, I just do a quick summary because some students just came here. Okay, due to the prayer or what. Okay, so in this chapter we study something called AC theory. Okay, this is a DC voltage source. Okay, in AC circuit, this is a AC voltage source. AC voltage source has a sine wave, so it's very obvious. Okay, so the AC voltage source. Okay, if you use the equipment to measure the potential, you will see sine wave. Okay, you will see sine wave. Okay, okay. And then in this module 1, we only study series circuit. Okay, your common test script later you add later, or you add later during the break or what. So in this module here, we only study series circuit for AC circuit, or we only study series circuit. We don't study parallel circuit. And the general formula, okay, for the AC circuit, you need to calculate something called impedance. Or impedance, to explain in the layman term, means it's an AC resistance. Okay, it's a AC resistance. Impedance is an AC resistance. So this impedance. So I will keep using this word impedance. Okay. That impedance. To explain in the simple way, it's the AC resistance. Impedance equal to R minus JXC plus JXL. AC here stand for what? Capacitor. Okay, L here stand for what? Inductor. This one is resistance now, as usual. Okay. Okay, so we are given this circuit. We are asked to calculate the current going through the circuit. So to calculate the current, we apply the Ohm's law. Okay, Ohm's law is I equal to B over Z. Okay, for AC is Z. For DC that we have learned in last semester, is R resistance. So that is what? That is using this formula to calculate. So this is a general formula that apply to all series circuit, okay, not parallel circuit. And so let's say you want to calculate XL. XL has the formula is 2 pi FL. Okay, the AC has frequency. Also take note, in AC circuit, this is where the frequency come in. 5 Hertz, 20 Hertz, the frequency come in. So in this question, what is the frequency? It's written here 400 Hertz, correct? So you substitute 400 Hertz inside here, and then so the F is 400 Hertz. L is over there, 5 milli. Correct. So milli is 10 to the power of -3. You press calculator, you get 12.57 ohm. Okay. So we still use ohm. Okay. It's just like your DC circuit, the resistance is ohm. And then now we want to calculate Z. So you just copy the formula. Okay. So you look at the circuit. Okay. Is there any resistance? In this circuit, there's no resistance, right? So R is 0. Okay. Okay. You look at the circuit, is there C here stand for capacitor? Is there any capacitor? No, so 0. In the circuit, is there any inductor? XL is calculated over here, 12.57. Okay. So you add up everything, you have J 12.57. Okay, then just now I explained complex number have rectangular form and polar form. Okay, 2 plus J3, when you see J, it means it's a rectangular form. Polar form is a number with an angle. Okay. You need to know rectangular and polar because you need to press calculator to convert rectangular form to polar form. So for example, you can press calculator from J 12.5, you will get 12.5790 degree. So this is polar form or rectangular form. This is polar form because you have the angle. This is the rectangular form. Then after that, next step, we apply the Ohm's law. I equal to V divided by Z. Okay. V is given 200 with the angle of 0 degree. So in AC circuit, the voltage and current are represented using complex number. So it's 200 volt with the angle of 0 degree. Okay. And then the Z, you just substitute here. And finally, how to do the division? I repeat again, this one you must know. So I was saying that you have the number part, the complex number have the number part and the angle part. We split into 2 parts. The first part is a number. So number is what? Is 200 divided by 12.57. So if you press calculator, you should get 15.9. Right? Okay. This is the third time I repeat already. For those students who are unsure for the class. Okay. For the angle part, the rule is the angle on top. So for example, the angle on top is 0 degree minus the angle below. So the angle below here is what? 90, right? So 0 minus 90, you get minus 90. So the answer is you get minus 90. So that's why you see the minus 90 here. And remember, for current is ampere. Okay. So do you have any question? So just to summarize, we only study series circuit, okay? And maybe I just write the formula here. You only study series circuit in this module. The general formula for you to calculate the impedance is this one. And SL is what? This is SC. So SC, the formula is 1 over 2 pi F capacitor, correct? The capacitor. SL is 2 pi SL. Yeah, that's all. Okay, so basically the formula is all here. Okay, so this formula 1, 2, 3, and then you still apply the Ohm's law. Current is voltage divided by impedance. Impedance come from this formula. Okay. Okay. So shall we do this question? You have to do the calculation and show me. Can you spend some time to read? Then I give you some tips for this question. Or read this question, take out a foolscap paper and do this question. Okay, you look at this circuit, there are two capacitors, right? You have two capacitors, C1 and C2, right? Okay, maybe I still give you some more time, okay? Get your paper, read the question. Okay, half a minute later. If you understand well, actually, if I don't explain, you might be able to do because I give you so many partial solution on the slide. Okay, okay. So you see, for the first part, you are asked to calculate the capacitive resistance, capacitive reactance. The capacitive reactance, the formula is this one: 1 divided by 2 pi FC. There are two capacitors, class. There are two capacitors. That's why for the first capacitor, you put C1, then the formula will be 2 pi F divided by C1 now. Okay, so you substitute the frequency 400 into here. This frequency is 400. You should get 13.26. Then for the XC2, you apply the formula, you should be able to calculate. Okay, so C2 is 20 microfarad. So far, is it okay? Then now we come to the impedance. Okay, so the impedance, this is the general formula, right? However, our circuit have two capacitors. So how you do it? Okay, the general formula still apply. Okay, so let's look at the general formula and how this C1 and C2 come in. So basically this part here is one capacitor. So if you have two capacitors, so basically you just so this one you have two capacitors. Okay, so for the first capacitor, it has X C1 line. We have calculated there. Right, SC1 there. So the same rule apply. For capacitor, always minus J or plus J. Minus J, right? So minus J. Then you have the second capacitor, C2, so you have XC2. You calculated already in this set. Right. Then for capacitor, minus J line. So you just put minus J. Yeah. So that means this portion, you have instead of just doing one, you just do two. Minus J something, minus J something. Right. So you can see from here, okay. Then equal to the resistance. Resistance in the circuit is 50 ohm. Right. Then the first capacitor C1 minus J 13.26 come from XC1. Okay. Second capacitor, you have to do some calculation. Okay. Then you will get this. This one is a rectangular form. Then you have to convert to polar form. So can you do all this first? Just do sequentially from top to bottom. One part here is you need to use calculator. Okay, you do this first. Then later on we do this one. Okay. So you just do sequentially from top to bottom. And for those students who have already checked your script, can you all place your script here? There are some script, some students, is it not here or what? Okay, so not here. Okay, so can you place your script here? Or just pass to the front, okay? Just pass to the front. I collect later. Just pass to the front. And for those students who need to do the test, you let me know. Okay, you can make an appointment with me. And the date for the retest is already announced in the red space. Okay, thanks. Just pass to the front. Micro. The micro is 10 to power minus 6. Always remember to write on the micro. It's the E micro. Then when you do calculation, you have to do times 10 to power minus 6. Okay, have you all marked the attendance already? If you haven't, can you mark attendance? For Friday prayer, you stick Friday prayer. I think now the tablet cannot work already because of the new software. Okay, let me try again. Can I try the tablet software? Can you come? Can you come? I don't know why the tablet software like cannot work. Is it really cannot work or what? Okay, thank you. See whether can work or not. Okay. Yeah, can work or not?
This thing you're trying to access back like this.
Huh? So I think cannot work.